Hey everybody, this is your pre-cal semester review. So we are doing 6.1 to 7.2, which is all trig. So to start with, it says choose the figure that shows the angle 10 pi thirds. Well, one thing you can do is you can just count with your unit circle 1 pi thirds, 2 pi thirds, 3 pi thirds, 4 pi thirds, 5 pi thirds, 6 pi thirds, 7 pi thirds. You want 10, 8 pi thirds, 9 pi thirds, 10 pi thirds. And so that's right there at 7 pi over 6. And so that'd be this answer at 7 pi over 6. That's by counting with denominator of 3. The other way was if you do 10 thirds minus 2 on the calculator. So I'm leaving off pi on purpose. 10 thirds and then minus 2. That gives you 4 thirds. And so then go to 4 pi thirds. And so that's right here. Okay. I don't know why I put 7 pi 6 there. That was incorrect. I meant to put 4 pi thirds. Because this was like 9 pi thirds and then 10 pi thirds was right there. At any rate, on the next one, what you do is you have your degrees. So this 33 starts here, and then you do 17 over 60 plus 31 over 3600. That's one of your formulas that you need. So if we do 17 over 60 plus 31 over 3600, we get 0.2919 and then a bunch of 4s. They just want two decimal places. So based on this 1, you round down, and so it's 33.29. On the next one, make sure your calculator is in degree mode. And do 65.34. Go to the book, and you have to be on the first tab in DMS, and just press enter. Oh, so I'm glad this happened. I was in radian mode, and I meant to be in degree mode. So click, and then this needs to be in degree mode. So 65, 20, 24. So that's how you do that one. It's going to show one more way. $65.34 enter. Okay, that didn't work. I guess with the older calculators, it doesn't do it. I seem to remember something. If I go 65.34, okay, it's not converting. You have to do your DMS. Oh, maybe it's because I was in radian mode. Okay. So anyway, make sure you're in degree mode, and you do your book, which is your catalog, and then make sure you're on the first tab and then go to the D's, the alphabet, D, and then scroll to DMS, and then press enter twice. So that's how you do that one. The next one, what we do is you have 55 degrees and you have to make that into radians. So think of being between 45 and 60. So you're going to be over here. How you convert it is you take your number and then multiply by pi over 180. And since it wants a decimal, then just go ahead and type it 55 pi over 180. Control enter, and I get 0.9599. And we have to round to 2 decimal places, so based on this 9 we round up, this one we ignore, and so that's 0.96. Ignore the last 9. Okay, so that's the first 4. Then we want the length of the arc. So this one you have a formula S equal R theta, and your radius is 14, and your theta would be 20 times pi over 180. So you do 14 times 20 times pi over 180. And that gives you 4.8869. And you want to round to 3 decimal places. And so based on this 9, we round up to 7. And then for your area, it's 1/2 r squared theta. So you do 1/2 times 14 squared times 20 times pi over 180. The reason why on both of these we had to use pi over 180 is because you were given degrees instead of radians. And so it's one extra step. So now I'm going to type 0.5 instead of 1/2, and then say times 14 squared times 20 times pi over 180. And I get 34.2084. And based on the 4, we round down, and so 34.208. Okay. Now on this one, you want to do your linear speed. So when we think of linear speed, that's like your miles per hour, or in this case, centimeters per second. So what you do is you have to have your centimeters on top, and then on your denominator, because it's going 1/6 radians, we have to do 10 times 6 in our denominator. And so that's why it's 11 over 60. Because you take the 10 seconds and then the angle. And it was already in the denominator. I mean, I guess you could have thought 10 over, you could have thought 11 over 10 times 1/6. That's the other way to think of it, but it does work out the same way if you do 10 times 6 in your denominator. Then on this one, you want your angular speed, and so you just do your 1/6 divided by 10 over 1 basically, and so that's 1/60th. Now, as far as your units, the first one was centimeters per second, and this one is radians per second. Okay. Now on this one, it says it's on the unit circle, so this is easier than you might think. Remember, we have x, y, and x relates to cosine and y relates to sine. So you literally just take your y answer and your x answer Now for this one, you want to do y over x, and so it's negative 1 over 4 square root of 5. If I were y'all, I'd probably leave it like that and just trust that's the right answer. The other way is to go negative 1 over 4 square root of 5 and multiply by square root of 5 over square root of 5. And then you get negative square root of 5 over 4 times 5, which is negative square root of 5 over 20. So it does all work out. It's just Math Excel accepts this answer. And that's also easier to flip because, I guess I put that there. If this is tan, then cotan would be 1 over tan. And so you'd say negative 4 square root of 5 over 1. And that's the negative square root of 4 square root of 5. Now speaking of flipping, okay, so as I was saying, speaking of flipping, cosecant is 1 over sine. And so you take this negative 1/9 answer and flip it upside down. Again, when we say flip, you don't flip the sign, you just flip to the reciprocal. So you want the reciprocal of that. Now, if you don't remember these as good, look at your unit circle paper, and on the back it says sine is 1 over cosecant, and cosecant's 1 over sine, and so forth. And also there's tan is sine over cosine, and cotan is cosine over sine. So that's on the back of your unit circle packet. And then the easiest way for me to remember it is C and S go together. So sine and cosecant go together, and secant and cosine go together. So you basically flip your answer. So I put 9 on top, and I put 4 square root of 5 on bottom, and I'm done. But if you'd rather double check to see if the paper answer matches, it'd be 4 square root of 5 and then multiply by square root of 5 over square root of 5 to give you 9 square root of 5 over 4 times 5. And so that's 9 square root of 5 over 20. So again, it does work out. But Math Excel would accept this answer, and it's easier. Now, on this one, we have to do 8 secant pi 6. So the first thing I do is I go to pi 6, and I write square root of 3 over 2 comma a half. What I did is I went to my unit circle at pi 6, and there's my word pair. Now my next step is secant is the same as 1 over cosine. And remember, this is x, this is y, so this is cosine, this is sine. So if I'm doing secant of pi 6, that'd be the same as 2 over square root of 3. And if I do cotangent of pi 6, that's like x over y, so that'd just be square root of 3 over 1, which is square root of 3. Now, the next part is don't forget your coefficients, because that would throw you off. You need to keep your 8 in front, and we said secant of pi 6 is 2 over square root of 3 plus 7 times cotangent of pi 6 is just square root of 3. So I would put that as 16 over square root of 3 plus 7 square root of 3. Now you're going to notice this didn't match up this time, but what you do is you rationalize this one and get a common denominator. So if you have 16 over square root of 3, you got to multiply by square root of 3 over square root of 3. And again, plus 7 square root of 3. this would be 16 square root of 3 over 3 plus 7 square root of 3 over 1. But what we want next is we want common denominator of 3. So that would give you 16 square root of 3 over 3 plus 21 square root of 3 over 3. And that's how you end up with 16 plus 21 is 37 square root of 3 over 3. And so that's why that really does match this answer. But on Math Excel, it would accept this answer. Math Excel accepts that answer. But this is how you eventually get to it. So probably if you look at view an example, it's going to show you a lot more steps all the way to here, but you could stop there. The other way just to say, am I right or not, is make sure you're in radian mode for this one. So I'm going to just call this the check. Be in radian mode. And so I go to here. And I'm going to do 8 secant. So I press the trig button, go to secant, pi 6, plus 7 cotangent, pi 6. As a decimal, whoops, I did times on accident right there. I get 21.36. And then when I do 37 square root of 3 over 3, I get the same thing. And when I do 16 divided by square root of 3 plus 7 square root of 3, I also get 21.36. And so all three of those match. Now, if you just started with 21.36, it's probably impossible to get to this expression or that expression. But that is just a way to double check. Okay, on this one, you're at -3, -3, +3, which is here. What that simplifies to, it's going to be like x squared root of 2, which is your 45, 45, 90 right triangle. Now the exception is it's a negative, but these are the same number, so that means this is going to be 3 square root of 2. That's the quick way to do it. But if you want to take your time, call it C. And you could say 3 squared plus -3 squared equals C squared. 9 plus 9, and that's 18, equals C squared. So C is the square root of 18, which is the square root of 9 times the square root of 2. And so that's, this is times. And so that's 3 square root of 2. So that's how you get that. And so basically you can even think of that as -1, 1, and 1 square root of 2, technically. Because when we do these, it doesn't use the 3 at all, because it divides out. So here's your angle touching the origin, and for sine you're doing opposite over hypotenuse, and so that'd be, first I'll do it the normal way, 3 divided by 3 square root of 2. Well, what does that end up being? It ends up being 1 over 1 square root of 2, which is 1 over square root of 2, which is really square root of 2 over 2. There, square root of 2 over 2. So if you do have the same number but a different sign, then the hypotenuse is probably that square root of 2. And then on this one, we do the adjacent over the hypotenuse, and so that'd be just basically the same thing, which is negative 1 over square root of 2, which is negative square root of 2 over 2. Again, MathXL would accept these answers. So what I'm looking at here is where sine and cosine are these values. So I'm at a negative cosine, which meant you have to be on the left, and I'm at a positive sine, which meant you had to be up. And so based on those conditions, you had to be in quadrant 2. And in quadrant 2, remember that sine would be positive, cosecant would be positive, and everything else would be negative. So cosine is negative, secant's negative, tan is negative, and cotan is negative. So if it helps you remember that, only 2 of them are going to be positive. And it's sine and cosecant. So that one, you'd take 1 over square root of 2 and flip it because it's 1 over sine. And if you didn't like flipping it that way, you could say 2 over square root of 2 and then rationalize. So that's 2 square root of 2 over 2, cancels, that's square root of 2. Now for tan, it is negative. It's basically y over x or sine over cosine. And so basically you have the same number except for it has to be negative. And your denominators cancel also. And then when you flip negative 1, you get 1. Negative 1 also, right there. And then for the secant, that's 1 over cosine. And so flip the negative 1 over square root of 2, just like you flipped that other one, but it's negative. So again, this one was positive, this one was positive, and the others were negative, based on where you were, since we were in quadrant 2. Okay. Now the next one, on this next one, we have g of theta over 5 if it's 300. So our first thing we do is 300 divided by 5, which is 60. Whatever number they have here should end up in quadrant 1. Okay. And now it's g of 60. Well, f is sine and g is cosine. Remember, sine is y, cosine is x. So if I go to 60 degrees, that's 1/2 comma square root of 3 over 2. And this is x, this is y, so this is cosine, this is sine. We want cosine, so that's the 1/2. So first step, divide, then write your ordered pair from the unit circle, and then do that. Okay, on this one, I did this problem twice on purpose on the packet and in the MathXL because it's one of the most commonly missed questions, and it's only a 1-part question. So let's see how that works out. You have cosine greater than 0, which means cosine positive, which happens over here because that's where x is positive. And then you have tan positive, which would be where it's plus plus and where it'd be minus minus. And so that's here and here. Now, based on this and this being your two conditions, you're in quadrant 1. So that's how you do that. Now yours may change to less than, and so you're on the left. It could change trig functions. I mean, but you go with cosine is positive on the right, cosine is negative on the left. Tangent is positive here and here, and so negative here and here. Now, this time what they did is they had cosine negative, and so that's cosine negative over here, and then they had tan positive, which was still like here and here, and so that's going to be this answer to meet both conditions. The other thing we didn't really talk about for those two was if it were sine positive, it'd be above. And if it were sine negative, it'd be below. So those are all your drawings. Remember again, cosine relates to x, tan relates to y over x, and sine relates to y. Okay. On your next one, we have tan, and if we're given sine and cosine, just do your sine over cosine. Compare your numerators, 2 square root of 5 over negative square root of 5, and that just gives you negative 2 because your denominators cancel. And so if you have negative 2, flip this and you get negative 1/2. So that's from flipping negative 2, like the reciprocal. Now for cosecant, you want to flip sine. The easiest way is start with sine theta is 2 square root of 5 over 5, which means 2 over square root of 5, and then flip that. So cosecant equals square root of 5 over 2. That's the easiest way, like if you just interpret it, because if you have a square root over a number, then that's just like square roots downstairs. The other way is if you start with 2 square root of 5 over 5 and want to flip that, that's 5 over 2 square root of 5. Then you're going to want to rationalize that. So you get 5 square root of 5 over 2 times 5. And then you can either make that 10 or just cancel your 5s. You get square root of 5 over 2. So it does all work out if you do your math properly. And then this one, you flip your cosine. So if you have negative 1 over square root of 5, and flip it, because that's what the negative square root of 5 over 5 is. Okay, for the next one, you're given a couple of trig functions, and we have sine as 1/2. So the first thing you think of is sine is positive 1/2, which means you're here and here or here. So that's where sine is positive. So if you literally look at your unit circle, I mean, if you do that for the y value, you're at either pi 6 or 5 pi 6, because that's where your y is 1/2. Now, for tangent being negative, it's going to be here and here, because tan negative would be where you'd have a negative x, positive y, or if you have a positive x, negative y. As long as they're different signs, then tan would be negative. So based on that, we need to be in this quadrant. And so that's the one at the 5 pi 6. And that ordered pair is negative square root of 3 over 2, comma, 1/2. And so x, y, cosine, sine. This is your x answer. That was your y, which was 1/2. Then for tangent, you're going to do y over x, or sine over cosine. And that's going to be negative 1 over square root of 3. And you could use that as an answer, or you can have it like square root of 3 over square root of 3, rationalizing. So that becomes negative square root of 3 over 3. Again, I usually prefer not rationalizing it, because right away you flip it. Because this is 1 over tan. And then for cosecant, that's 1 over sine. And for secant, that's 1 over cosine. So same thing we've been doing. So this is flip 1/2. And this one you flip. So it's this. So that'd be negative 2 over square root of 3. And again, I would answer it that way. Or you could have it as negative 2 over square root of 3 times square root of 3 over square root of 3 gives you negative 2 square root of 3 over 3. And so it all does work out that way. Okay. Now for your next one, we're doing the cosecant even odd property. If we're going backwards pi thirds, that'd be the same thing as going forwards 5 pi thirds. And that ordered pair is 1/2, comma, negative square root of 3 over 2. So again, the minus angle means you're going backwards. So the next thing is cosecant is 1 over sine. And again, x, y, cosine, sine. So if sine of negative pi thirds equal negative square root of 3 over 2, whoops, I put negative twice, then cosecant of negative pi over 3 would be negative 2 over square root of 3. And again, I'd answer it that way. Or you can have negative 2 over square root of 3 and rationalize. So you get negative 2 square root of 3 over 3. And that's what they got. Okay, there's the first 15. Now we have totally different type problem, because now we're on 6-4. Remember, this is the section number and then the problem number. So now we're on graphs. And so make sure that your F1 part is in radian mode. So we go to add graph. I am in radian mode. And I do 7 cosine x. So it's there. Basically, I could adjust my y values if I wanted to. I don't really need to, because I know that this is going to be the same as this, because since it's cosine, the amplitude is the same as the y-intercept. Okay. If you want a way that always works, go to your table and go to your table at 0, and you got 0, 7. If it's sine, the y-intercept would be 0, 0. If it's sine, the y-int is 0, 0, so the answer is 0. So your next part is, where is it increasing based on this interval for x? And so we want to get rid of our table, go to our settings, make it negative pi to pi. If this is negative pi to pi, that's literally 1 period worth, because here's 1 pi, here's another pi, so that's 2 pi's. And it's increasing from negative pi to 0. So that's this answer. So just graph it. And then the absolute maximum would be up here, which is 7. And then now you have to change intervals. So you're showing, okay, this one showed 2 pi as the period. Well, on the graph, 2 pi on the graph. And this one shows 4 pi units. So what we need to do is say that's 2 periods. And go menu 4, 1, go from negative 2 pi to 2 pi. And now we want where it's 7, which is where it's up top. So that's at negative 2 pi, 0, and 2 pi. Now, on some problems, it may not be as obvious as this. And so if you want to make your y parts like negative 10 to 10, then it could look like that. And if you put y equals 7 like this, then you can do your intersection. So it's going to be tricky against the side. I don't think it's going to work. No, it didn't work. But it got this one, which was 0 to 7. So what you'd have to do is just zoom out. And then you can get it. Menu, analyze, intersect between here and here. Now it says negative 6.28. So this would be negative 6.28 to 6.28. Just like this would be negative 3.14 to 3.14. So that's why on this one I get 3 answers, because it wanted the maximum. Now if I go back to my window and put it how I was wanting it, from negative 2 pi to 2 pi, and I'll still put negative 7 to 7. If I do that, you'd notice it asked for the maximum, which was where it's positive 7. So I have 1, 2, 3 answers. If it had asked for where it was negative 7, it'd be 2 answers. So it just depends on what it wants. And then for this part, you want your x-intercept. I've thought about different ways to show you all this. The easiest way to me is an integer would be like 1, 2, or 3. And so if you put this in your table, go to our table settings, go to Menu, Table, Settings, start your table at 0, and then step by 2 times 1 times pi. So that's stepping by 2 pi. Here I just get, well, I got errors because it didn't like it. Menu, table, settings. Okay, it just did not like that. If I go to the table settings, basically that's going to tell you that's not the answer. Now on this one, if I do 2 times 1 minus 1 over 2, that'd be like 2 minus 1 over 2, which is 1/2. And so step by pi halves. So we want this is 0 and this by pi halves. So then I can see it's alternating between 7, 0, which is pi halves, -7, which is the minimum, then back up to 0, which is 3 pi halves, and then to 7, which is 2 pi. So it didn't give me an error message on that. Now you know when it recalculates this, sometimes it may say odd integer. So an odd integer would be like 135. And so you can test different values. The other way, if you don't want to mess with your table settings, is you could have done 7 cosine of pi halves. Seven cosine pi over 2, as long as you're in radian mode and you get 0. Okay, so that's how you do those. That's a good stopping point for this video. Then I'll continue to the next. Have a good one. Hope that helps.